Okay, Assalamu alaikum and a very good afternoon, everyone. This is Hasib Manzoor, and likely I would be the host of this session today. So, yeah, without further ado, let me share my screen with you guys. Again, warmly welcome you all towards the session today, which is basically our webinar. Omics Nexus present a webinar series. Lastly, we had a webinar on bioinformatics. So this time we have a webinar on from data to cure AI and bioinformatics in modern healthcare. So again, I welcome you all for today's session. Without moving into towards discussing more about AI and what's the link of AI and bioinformatics and what are the trends going on in today's science. So I'll just discuss about Omics Nexus. So so what is Omics Nexus? Basically, what we are trying to do here, we are making bioinformatics accessible to everyone. What we are doing, we are redefining what it means to be a scientific solutions partner. We go beyond the typical service model. But basically, in terms of deep learning expertise, we have the expertise in bioinformatics, NGS data analysis, multi-omics, AI-based biomarkers discovery, pipeline development, meta-analysis, systematic reviews, scientific writing, and healthcare business development to deliver data-driven impact. So apart from what we are, basically Omics Nexus, it's a company. Just kind of what we are trying to do, we are making bioinformatics accessible to everyone. Apart from the services that we are providing to the clients, what we are trying to do कि हम लोग जो हैं that are passionate about bioinformatics हम उनको जो है एक awareness दे रहे हैं basically what bioinformatics is. Apart from our paid services, we are giving some free webinar. We are educating people in Pakistan who are very passionate about exploring the future of bioinformatics with us. So yeah, this is a chance to connect with you all. Okay, so मैंने Omics Nexus का इंट्रोडक्शन करा लिया कि what basically Omics Nexus is और इसके अंदर हम लोग क्या सर्विसेज ऑफर करते हैं. We are delivering advanced bioinformatics and AI solutions that drive smarter, faster healthcare decisions. इसके अंदर we have the bioinformatics. We are providing the services of bioinformatics where we extract meaningful insights from the complex biological data set with precision and accuracy. We're also proficient in AI and machine learning where we leverage intelligent algorithms to predict outcomes and accelerate the research discoveries. We have automation and pipeline development efficiencies. We streamline data processing with customized, efficient, and reproducible workflows. We are proficient in statistical and data analysis, where we turn raw numbers into actionable conclusions through advanced statistical methods. Also, we have expertise in content drafting and illustration, where we communicate science clearly with impactful writing, visuals, and graphical abstracts. We are also giving services on research project development from idea to execution. We design and structure the research projects for maximum impact. We also provide consultancy services, like if you have some question regarding your research or you need guidance, you can get expert guidance from getting the raw data towards the data analysis and efficiently solving the scientific problem. We also provide one of the important aspect of Omics Nexus is we also provide trainings and workshops. We also, along with that, with paid trainings and workshops, we also do a free webinar series where we offer insights on the certain topics of bioinformatics. So I would just say, please stay tuned for this specific domain. Okay, so what sets Omics Nexus apart? We have the multidisciplinary expertise. We provide tailored end-to-end solutions. We provide free consultations. Definitely, if somebody asks us regarding their project or regarding, if he needs some at some to some extent, I would say, if we need guidance, we always provide free consultations. We have proven results in client trust of more than 99% client satisfaction, and we are always on spot. You can reach out to us in obviously for any services that you have. Okay, then I'll just quickly introduce my team. We have Nadeem Khan, who is the founder of Omics Nexus and a bioinformatician. He's specialist in NGS data analysis, docking, and simulation and bioinformatics project development. Then this is me, Hasib Manzoor. I'm co-founder and also a bioinformatician. And yeah, I'm coming from a strong background of bioinformatics with my BS and MS both in bioinformatics. So I'm specialist in metagenomics, machine learning-based biomarker discovery, and science communications. Then we have Munib Nasir. He's also co-founder and bioinformatician. He's specialist in bioinformatics, pipeline development, docking, simulations, and he is also proficient in providing the consultancy services for bioinformatics. We have Hazrat Maaz, who is also a co-founder and a bioinformatician. He has expertise in applied AI and machine learning, bioinformatics data analysis, web development, and IT. Okay, lastly, I would just give you a highlight of the events that we have conducted so far. We had me along with Nadeem Nasir, we have trained people on metagenomic analysis using Linux and R programming. It was a 2-week crash course where we covered different aspects of metagenomics. Then we had our first free webinar. This is a webinar of Bioinformatics Starter Kit. Okay, this is one of the webinar which also motivated us to start a free webinar series for Omics Nexus, and this is the very reason that we are here today for our next free webinar. And yeah, again, the next webinar is from data to cure AI and bioinformatics in modern healthcare, which is we are conducting right now. And I'm really hoping that you guys have a great session. I know there were certain issues in terms of your technical issues that we really look forward in looking into that what were the reason behind them, and hopefully we'll come up with more energy with more such events. And definitely you should stay tuned with us for such fruitful sessions and value pack sessions in terms of bioinformatics. Just to give you a highlight of our upcoming events, we have a workshop upcoming, which is decoding lung cancer progression through transcriptomics data analysis, where we will be exploring molecular driver of lung cancer through multi-stage transcriptomic profiling. That would be a training workshop. Then we'll have another training workshop from data to discovery, scientific visualization in R for biologists. You will learn to transform raw experimental data into interpretable scientific visuals, which is again one of the very important thing for a scientist to have his idea, the scientific idea, to be in an impactful visuals. Okay, then we'll have a training session on machine learning for gene expression classification, where distinguishing disease phenotypes. Basically, it would be a hands-on workflow for building, training, and evaluating disease classification models. So these are the 3 planned workshop series that we'll be having very soon and we'll be announcing very soon. So I would just urge you all to please stay connected with us in all the social media platforms, and definitely we would need your the outreach. We would need your outreach. Please share these events when we announce with your classmate, with your group, so you can have the more benefit of this session. Him. So we had the speaker, we had Aman Safi. He holds an MS in bioinformatics. He's specializing in structural bioinformatics with a strong focus on AI-driven protein design. His work centers on leveraging intelligent computational tools to accelerate therapeutics discovery and improve healthcare outcomes. Okay, lastly, I just pasted the QR codes of our social media platforms. We have a WhatsApp channel and the groups. We have YouTube channel where we'll be posting all our sessions as well. We have Facebook, Instagram, Twitter, LinkedIn. So please, I would just urge you all to please go follow our social media platforms. Uh, to stay informed and stay ahead, and stay up to date with us.
Hello, everyone. Sorry, I think there is a problem with the internet at my side. Am I clearly audible?
Yes, sir, you're audible.
Okay. Thank you so much. So without further ado, let's start our session. So my name is Aman Safi, and I have a master's in bioinformatics from NUST. So as my specialization, you have already read about it, that it's in structural bioinformatics, specializing in computational protein design. So about this webinar, we will mostly be talking about the bioinformatics and AI in modern healthcare, but from an beginner's point of view. And I will make sure that all the technical jargons are addressed in the question answer session for those who have already some knowledge about this from their own sources. Okay, so let's start. So these are the contents that we'll be discussing about. So starting from introduction to AI, applications in healthcare, bioinformatics, which is the foundation, bioinformatics and AI, how this synergy is going to change the landscape of the healthcare industry. And we'll also talk about some real world examples and the success stories that we have heard in the past few years, and what are the current limitations and challenges which we are currently facing and we might face in the future, and how exactly the future trends are going to be in this area. So by starting, before we start the session, I just want to make sure you guys do a small activity from my side, which will be what comes before we start this session, what comes to your mind when you hear artificial intelligence in healthcare? And the second question is, what is your current understanding of bioinformatics and AI? I want you all to take 5 minutes and notice these, write these questions down to yourself, and no need to answer right now. Just keep these answers to yourself. And after this session, I want you to write answer of this question, which is what one new thing that you are going to learn after this session, and how do you think that AI might be able to change your own area of study or career in the future? I want you to keep these answers to yourself. No need to share with anyone. Just this is for your own evaluation. How exactly you are going to learn before, how, what was your how to say knowledge of the AI and bioinformatics before this session, and what was the after this session, whether it aligns or not. So you will be the evaluator for this one. So simply explaining what is AI, it is basically machine intelligence that can simulate human reasoning and learning. So how we say that what is reasoning and learning? Human beings are designed to perform certain tasks that only they can do, maybe not that is not present in other species, but some like speech, for example. So AI is just how to say an infant baby that we are trying to teach something to speak. Suppose like an human child, AI is also an infant. It's clear mind. Doesn't know how to speak, how to write or do anything, any other task or a complex task that human beings can do. We teach infant baby to speak. It tries to utter some word. It makes some mistakes, and it learns from those experiences. And when it is adult, when it is fully mature, it can speak clearly. Like we all talk, we all see things, we all know how to judge an object which is far, which is close, and so on. So what exactly, how exactly this mechanism occurs is that AI learns from the patterns and makes decisions, same way the human beings do. And another thing is that it also improves with experience instead of the manual programming. In traditional programs and in traditional softwares, we used to introduce new updates or new set of programming that we had to do manually. But instead in AI, it's not the case. We have a new data. By the time we just give it new data, we train on it, train this AI on this new data, and it gets improved over time. Suppose, for example, if I give you example, the earlier version of the chat GPT used to tell everything, yes, you are true, yes, you are true. Now it can actually distinguish between which is a false information, which is a correct information, but still there is a room of improvement still needed. And obviously, we know that it can powers new some devices or some softwares, which is like smart assistants, self-driving cars, like for example in Tesla, and medical AI tools as well. So smart assistant is an example of earlier ones are, you can say, Google Assistant, and Apple has Siri in iPhones. So how exactly it is catering healthcare? Thing is, AI is not itself doing anything. It's not doing the heavy loading. Here, heavy loading is still done by the human as well, but it can help you analyze the complex medical data at the scale, which is how to say it increases your productivity. Not it is like how to say doing entirely your work, but it is actually helping you do the heavy lifting. Another thing that it helps you makes you decision more accurate and with precision, and your decisions are more personalized. From disease detection to virtual assistant, we have AI. It can also help us to detect detect diseases, and also helps you to understand how exactly this whole process of detection to treatment can be carried out as a co-pilot for all the process of disease detection to the treatment. And in the new cases, we have also observed that we have some AIs that also help us to predict structures of the biomolecules. And also, not only that, it is also going towards the designing of these new compounds as well. So these applications, how exactly these applications in healthcare are going on these days, is that it helps in AI-based medical imaging. For example, you can detect normal versus tumor in histopathological slides. Another one is that you can also scan MRIs, and you can also make decision out of it that whether the human person has a tumor or not. Another thing that you can do CT scans as well. This is also being used in the CT scans to make decisions faster. Normally, MRIs and CT scans are very hard to interpret for the medical doctors. So AI can help you reach the decision faster. Okay, moving on. It also helps us in the predictive analytics, like early detection, starting from the clinical data mining. So the patient records are being used to feed the NLP models to understand how exactly the patient symptoms are working for the disease. Do they correlate or not? And it can help medical practitioners to reach their decision faster. Another thing is that the drug discovery and screening molecules has become more easier. So designing new compounds to predicting the structures of the protein, AI is being used everywhere. So moving on, how exactly the bioinformatics is helping in all this scenario? Basically, bioinformatics has been around here for, I think, maybe 20 or 30 years. But still, it's in the limelight. It came into the limelight in the last decade. Why? Because it combined computer science, statistics, and mathematical models, and applied them into the biology. This was entirely something new that people didn't realize in the beginning. But so by using all these techniques, bioinformatics helped in the biological experiments. And after that experiments, we got multi-omics data. And this multi-omics data was further processed and stored into big data centers that helped us to train AI models. After training those AI models, we realized we are able to reach to the precision medicine more faster and more easily compared to the traditional hit and trial methods. So moving on, AI and bioinformatics form a very powerful synergy. How? The AI is very good at recognizing the pattern in the data, whereas the bioinformatics ensures the accuracy and precision. With this synergy, we went to drug discovery more faster. The recent example, we have the vaccines of the COVID. Normally, a vaccine or a drug discovery process takes maybe 5 to 10 years and costs more than $10 billion for even a single drug. But with bioinformatics, this process was reduced from 6 months to 18 months. And we realized that after even maybe after 1 year and a half during the pandemic, we had vaccines from all over the companies. There was a European vaccine, and eastern side there were the Chinese companies that were making their own vaccines. So it helped us to reach the targeted therapy. The drug in the beginning, the drug discovery method was all about hit and trial. We screened a lot of drugs, we failed, and the process was repeated again and again. But due to the bioinformatics and AI, this process became very targeted and very precise and very specific. And obviously, the end result is the personalized therapy. I think the personalized therapy, we have been using this buzzword for 5 to 6 years, but still in Pakistan, it is still used as a buzzword, but in the Western world, it is happening. We see that there are two available startups that are actually catering this personalized therapy for every patient, for very specific for every patient. So some real world examples how exactly AI is being used in all this scenario. We have the first and foremost example of the AlphaFold, which came out in 2020 by Google DeepMind. So it was actually used for the prediction of structures of the protein. So proteins are simple strands of amino acids that fold into form uh, a protein, a 3D globular molecule. So these, by understanding the structure of the proteins, we can understand how these proteins are actually working inside the human body, how these perform functions. From therapy, from disease diagnosis to therapy, proteins are used everywhere, even in the food industry, even in the cosmetics, even in the uh, even cosmetics and even detergent at an industrial scale. These are used in the detergent and cleaning industry as well. So these biomolecules have enormous applications, yet we have a little understanding of them still. Another example is RF diffusion. This model came into scene in 2022, where David Baker and their lab colleagues introduced an AI model, a diffusion model that can design new proteins. So it is said that there are more proteins in the galaxy than the galaxies itself, than the galaxies itself in the universe. So you understand how these proteins are actually very important in this whole scenario. So another example by a pharmaceutical company, Sanofi, they introduced a new AI model, which is basically multi-agent model, which is able to understand the natural language in which we are currently talking and speaking and writing and doing other things. This natural language, uh, this is basically based on the multi-agentic AI system. So these multiple agents are working in a whole synergy, and they're at the background. They're all doing all the heavy lifting for you, like from doing RNA sequencing analysis to ChIP-seq and every other multi. So this talk to biomodels is basically able to predict the drug response before even going to the clinical trials. 90% of the drugs fail because uh, these pharmaceutical experimentations and all these procedures are not, how to say, are not catered according to the patient's genetic profiles and their epigenetics. So before even going to the clinical trials, these companies are making sure that they are able to predict the drug response before they're going into the population. And the success story, you most of the people might have heard about it, is that AI helped us solve a 50 years old problem, which is called the Leventhul's paradox, or more common in a more common sense, it is called protein folding problem, which was solved by the AlphaFold in 2022, and which laid the foundation of the generative biology, which I already gave you example of the RF diffusion model, which is called the Rosetta Fold diffusion model by the David Baker, Baker's lab. And AlphaFold was presented by the Google DeepMind team by John Jumper and Demis Hassabis. So they helped us solve the 50 years old problem, which is called the Leventhul's paradox. What exactly is this paradox? It says that protein has to go millions, or maybe I think a lot of uh, conformational states before it folds into a very stable structure that we observed, which we currently you can see on my screen. So before falls the exact folds, this very exact fold, it goes through a lot of conformations. So in the simple words is that two proteins will always fold into the same structure as long as they have the same FASTA sequence. I hope you get my point. So it's a very beautiful paradox, or better, beautiful phenomena in which the protein folds itself into. And for this, they got a Nobel Prize in Chemistry in 2024. So many people are still skeptical about why these guys were given Nobel Prize. It's a little bit controversial take on this, but I will just explain why they deserved it. Is this because
They helped us solve all the structure of all those proteins that are known to man. Okay, let's moving on. So still, after all these wonders that AI is doing, there are still current challenges and ethical considerations that need to be taken into account. First is that the data privacy and patient consent. That is the biggest problem and challenge that we are facing for the AI, is that many of these companies like OpenAI, Claude, or Anthropic, and all these companies are already training their AI models on the internet data. But are they taking data privacy and patient consent into account or not? It is still big challenge. Yet they are owning these AI models that have been trained on the public data sets. So it is a big conundrum. Moving on, AI has currently some very algorithmic biases and data imbalance. Why? Because currently the data we have is very, how to say, is very biased, because most of the data currently or publicly available is in the hands of the developed countries. They are not taking account the norms and the customs, or you can say the laws or the legal implications that are in the developing countries or other countries. So one data of the country varies from another country. So it obviously creates a data imbalance. And next, the interpretability of the AI models. So this is one of the biggest conundrum here. How to say that, how exactly AI is making decisions, we don't know that. What exactly happens inside the neural networks, no one knows. That's why they are called as a black box. A simple black box is a physics mechanism in which uh, whatever happenings inside the universe or in the black box, we don't know. Whether we give input and we get the output, what exactly is happening between the AI models, we are still unable to solve that. And how AI reaches its decision and makes the reasoning for itself, no one knows. And this is another big, it's a hardware related issue, is that currently these AI models are very compute and data intensive. So not everyone and not every country, or not how to say, every organization is able to afford these AI models and use them on their problems. So what is exactly the future trend of this bioinformatics and AI? Is that AI-driven therapeutics are becoming more common. We have seen that AI-based protein design, AI-based protein structure prediction has been seen a lot these days. Another one is that we can integrate multi-omics data into the AI and bioinformatics. At the same time, we get uh, amazing outcomes. And these AI-assisted discoveries are becoming more and more common. You will be able to see these discoveries more common in the near future. And the market trend says that this AI and bioinformatics global market will be increasing by 43.7% through compound annual growth, and you'll see that $26 billion of market size is going to be. So that's all from my side. Thank you, and I'm open for your questions.